This is a explanation for task 4.1. So this is technically a light control system which uses the RIP sensor and the BH1750 system to control the action, and also we have a switch. So the logic of this code is like the LED turns on only when the motion is detected, the switch is on, and the light amount is below the threshold. So as you can see here, we have our pins. So before that, we have our libraries, and here we have an object from the class of the BH1750 object from this class. And then we have our pins here. The PIR sensor is connected to pin number 2, the switch is connected to pin 3, and the LEDs are connected to pin 4 and 5. We have our interrupt variables here, which we set as false at the beginning. Then we try to actually trigger these interrupts during our loop. Then we have our states, which technically manage the logic of the program. Then we have our light threshold, which is 50, and then our motion timing, which technically controls the timing of the program. And then we have our switch variables controlling our switch, which technically this is just for preventing the false multiple triggers from a single press. So each time we turn off or on the switch, we also have other single signal presses. So that's why that we need this to avoid that false multiple triggers. And then we just have our setup section here. So we have our just PR pin as an input, our LEDs as output, but the switch is as input pull up. So this is technically means that the pin reads the high when the switch is open, and it just reads the low when it's closed. Here we have we are using the I2C to communicate with the BH1750, and we start the communication by using the wire begin. Then here, so technically I use this section for being sure that my BH1750 sensor is working correctly. So during making my circuit, I had a problem because it seems that this sensor is really sensitive to noises. So I was using a same ground pin for both my RIP sensor and the BH1750 sensor. So because this one is really sensitive to noise, I had to use separate ground, and I didn't know that. So each my sensors were working separately correctly, but when I just using it for whole in both of them in one circuit, I had a problem. So I just use this to be sure that it is found by the program and it's working correctly. Then here we have our interrupt. So interrupt are special functions that trigger immediately when a pin is changed, without waiting for the loop to just run. So we have two triggers here, as you can see. The first one is the for the PIR pin, which just calls whenever the PIR pin changes. I mean, maybe high to low or low to high. As you can see, it just calls the PIR ISR function a method here. It just both of these interrupt method just simply change the flags. If they're false, just make them true. And then we have another interrupt for the switch as well. It is called whenever the switch pin changes. Both of them interrupt functions just do not run the main code, and as I said, they just just set a flag technically. So now let's move to our loop section, which the main code is running here. Here we have our motion detection logic. So first of all, we have our technically looks the value, which just reads the amount of the light and then just save it here. Here we just read the digital pin. If it's high, if it's equal to high, we just return the true to the motion detected. If it's low, we just return false. So this is for technically a bool, as I just defined it here. It's a as I defined it here, it's a bool value. And then if the motion is detected and is true, we just save the now time in the last motion time. Then this will technically this part of code will just keep it active for 3 seconds after the detection, and it just prevents the LED from turning off immediately after a short PIR low signal. Then we have our switch handling here. If a switch is true, we will just come here. Firstly, we will just set it as false. It would just reset. We just reset the flag, and then we check here for preventing multiple triggers from one physical press by using the as I mentioned before, these variables. And then we just update the switch based on the pin state here. And here we just control the LEDs. If the motion is detected, if the switch is on, and if the light level is below the threshold, the LED will turn on. Here we just writing our digital pins the state of this LED. If it's high, it should be high. It should be written high to the digital pin for the LED 1, and same happens for the LED 2. And at the end, we just print the output of our code. What is happening here? What exactly are the outputs of our sensors, and what is the situation of the switch and the LED. So that was the code. I will just move to explaining the thing happening on my circuit and show you what is happening exactly on that, and then show the output of the circuit in the serial monitor as well. So here is my circuit. As you can see, the LEDs, the switch, and the RIP sensor is connected to their pins, and also the BH sensor is here connected to the SCL and SDA pins here through the A4 and A5 pins. Then each of them are connected to their ground or their 3-volt pins as well. So here I just uploaded the code. Here is the output in the serial monitor. So as you can see, because at the moment the switch is on and the it is dark, the amount of light is less than the threshold, and also the motion is detected. As you can see, it says that motion is 1, so it means the motion is detected. If the motion was 0, it meant that there wasn't any motion. So that's why the lights are on. So the thing I would just do now, I will just use my phone to give an amount of, as you can see, because the amount of the light is more than the, so now is not, yep, it's more than the 50, the lights are not on now, but if I just took it again, they're on again. So one more thing I will just do is I will just turn off the pin. Yeah, as you can see, they're just turn on again. Even if I bring the light, they will not turn on because the switch is off. So yeah, that was my project. Thank you for your attention.